right, so we want to do an example here now that we've talked about vectors in space. And we've got 3 points in space, 3, 4, 1, 0, 6, 2, and 3, 5, 6. And we want to see if, when we construct that triangle in 3D space, if we're dealing with a right triangle, an isosceles triangle, or a scalene triangle. And if you recall, scalene triangle just means that none of the sides match. They're all different lengths. Isosceles, 2 of the sides match. And right, usually two of the sides don't match. It could happen, but obviously a right triangle has satisfies the Pythagorean equality. So let's get to solving. So the way we would want to do this is we want to label these points. We're going to call this P, Q, and R. And then we're going to come up with 3 vectors that represent P, Q, and R. We don't have to do it that way, but that is a way to do it. So we're going to represent the segment from P to Q as V. We're going to represent the segment from Q to R as U, and we're going to represent the segment from R back to P as W. That way we cover all the different ways that these things interact. And the order doesn't really matter because we're only going to be dealing in the magnitudes here. So to get PQ, we want to take those differences here. So that's going to be -3, +2, and +1. And then if we get U, so that's the distance from Q to R, so it goes 3, -1, 4, and then for W, again, that's R to P. So this is actually the terminal point here. So that's going to be 0, -1, -5. And then we want to go ahead and get those magnitudes. So the magnitude of V is 9 + 4 + 1 is the square root of 14. The magnitude of U, 9 + 1 + 16, square root of 26. And the magnitude of W, 0 + 1 + 25, is the square root of 26. So, since these match, it's an isosceles triangle. Now you might also ask yourself, is this a right triangle in addition to being an isosceles triangle? And the answer is no. And the easy way to figure that out is that in a right triangle, the longest side, or in an isosceles triangle, 2 sides are equal, but in a right triangle, the longest side can't be equal to either of the other sides, otherwise it wouldn't be the longest side, and the odd man out here is shorter than these 2 sides. So we know that it's not a right triangle. We could have verified that. If we didn't know, we would have taken the 2 smaller sides, squared them, and seen if it was equal to the square of that third side. That's how we could have verified it was a right triangle. And then obviously scalene is if they didn't match at all. So that's it.